Hey everybody, we are back. Today it is Science Day, so we're going to look at elements and atoms. Again, this is not my PowerPoint. It was created by G. Barber, www.sciencequeen.net. So I'm using her presentation. I always want to give credit to the people who made the PowerPoints. So here we go. Try to get it in 15 minutes or less so that you guys have time to look at it and deal with anything. Remember, stop it, rewind, go back for if you need to look back at something a little longer. I will post the PowerPoint on the site along with the pages to try today. All right, so when we talk about matter is anything that's going to take up space and has mass, and all matter is going to be made of atoms. So when you guys look at some things on here and you talk about atoms, you're talking about the matter. So basically everything that is existing here, that's what we're looking at. When we look at specifically, you're going to have questions on protons, neutrons, electrons when you're on the test. Protons are positive, neutrons are no charge, electrons are going to be negative. You're going to find protons and neutrons in the center here. And then, of course, the electrons are going to be the ones that are going to be orbiting around the nucleus. So be mindful of that, depending on how they ask the question on the science test. Next thing we're looking at is the elements. And when we talk about the elements, we're basically talking about the molecules themselves. They're made up of a specific element. And of course, we will look at those not in depth. You don't have to know it in depth. You just kind of got to have an understanding of it. That's all. When we talk about atoms, here is one for you. When you have hydrogen, notice again, protons and electrons are going to be the same. Neutrons, not so much, and we'll talk about how in the world do we calculate neutrons, and that's something different. We'll look at it. Helium, same thing, 2, 2, 2, 6, 6, 6. Again, protons and electrons are always going to be the exact same number, but there could be a difference when you're talking about the neutrons. Here we go. Elements, like we said, elements are going to be found in the periodic table. Now, the periodic table has a list of all of the elements. You guys do not have to know that table, but you may have a question or two that's related to the periodic table, so kind of look out for that. You can Google periodic table and you can see all of the elements there. I just want to make sure you guys know how to read an element that's found in the periodic table. So let's take oxygen. Going to take a second, make sure you know how to read it. So first number up there, that's the atomic number. Atomic number, again, is the number of protons and electrons in an element. So there are 8 in oxygen. Then, of course, that O there is going to be the abbreviation. We use O for oxygen. So remember all those capital letters, a combination of capital and lowercase letters, they're going to represent different elements. So that helps. And then again, when we're doing balancing of the equations in terms of elements, we will chemical equations. That's the word I was looking for. We're going to be looking at, they have the abbreviations in them. Okay, so that is the element's name, oxygen, and then of course that 16 at the bottom is the atomic mass. So that's the number of protons and neutrons. So remember earlier we were talking about, well, how do I figure out how many neutrons are in an element? Well, if I know how many protons are in there, that number up here, and then I know the atomic mass here, I can subtract them from each other, and that can give me the number of neutrons if I'm ever looking for it. Just a FYI, they're not going to make you do that on the test, but just in case, so you know. So then there are 2 ways that we can show, or they may demonstrate the elements on the test, either the Bohr method or the Lewis dot structure. Most cases that I've seen, they look like the Bohr model here, where you have the nucleus, which has the protons and the neutrons in it, and then it has the electrons orbiting on the outside. That's usually the way that I've seen it on most of the presentations that we've had. So I'm going to lean towards this being the model that they're going to use on the test. They make it more realistic, but it's usually still the same type of model. When we talk about the electrons, they have energy shells, and the shells have certain rules to them. Wanted to show it to you. Notice the nucleus is always in the middle. Then you have your first shell, and it only holds 2 electrons. Second shell can hold 8. Third shell can hold up to 18. I don't think you have to know this, but sometimes they, just so you see them, when you see the different electrons orbiting around, you understand why. Well, I only see 2 here. Why do I see so many here? Why do I see so many here? This is why. Okay, because they do have rules to where the electrons can go. Here we go. when we talk about the electrons can, of course, change and go or bond with different things. And I'm not going to get into bonding because I know that's not my forte. It's more sciencey than I'm comfortable with. But it is, I do have a PowerPoint on it that I'll share with you guys so that you can kind of look at it and deal with it. And we'll try. I'll try to get it as good as I can. Okay. Now, when we look at lithium, this is lithium. Remember what this is. 3 number of protons and electrons, the abbreviation, the name, atomic mass. So then if I wanted to find the number of neutrons that would be in this, I would subtract the 7 minus 3, and that would tell me I would have 4 of them. So if I looked at this in terms of the model, notice I got my 3 protons. I have 4 neutrons because I subtracted 7 minus 3 to get the 4. And then I have my electrons here orbiting outside. And again, because there are 3 of them, remember, only 2 can go in the first rim, the first shell. So then I put the other one out here. And I would have, if it would have had more, I would have added more on the outside, but only had 3, so I added 1 more on that other level. The other, boom, boom. Okay. The other structure is the Lewis dot structure that's here. I have not seen a lot of them that look like this, so I would not say that that'll be on the test, but just in case you kind of have an idea of what they did here. They know that you know how many protons and neutrons, I do that all the time. Protons and neutrons would be in the center, so all they did was put the number of electrons on the outside. Again, I'm more comfortable with this model than I am with that, and I think this is the way that I've seen it on most of your practice tests, so we're going to assume this is the method that they're going to have on the test. All right, guys, I will put your page up. Enjoy. Talk to everybody later. Bye.